So I think the first part is to understand that in this case here, Leate will fail. You can't use Leate here because this is A and A, algebraic and algebraic here. Okay. So this is a very common kind of question where Leate will not work. Okay. So how do you by using by parts, because by parts means Leate lah, but a lot of students swear by Leate. This is where if you swear by Leate and don't know what is a core concept there, you mess up. Now the U here, what you need to understand is the U, right? When you choose for 2A, right, you need to choose the one which will disappear first. Now you have two candidates, right? You have two candidates here to be your U. One is X and the other one is 1 minus X half, okay? It doesn't have to tell you long that if you differentiate these ones, it becomes a constant straight, it will disappear, okay? So this one would not be lah. You will not disappear because if you differentiate this will need to integrate ma. So you just take note if you have AA. So for example, right, I'll give you an example. If say you have like say x squared and like 1 minus x to the power of 10 dx, okay? It's very clear that your u should be ux squared. You need to do by parts twice. Because right, you differentiate this twice, and d square u dx square, you straight away become a constant. Okay? So the idea is you pick the u. If you have 2a, right, pick the u which would give you a constant first. That is the idea lah. So anyway, this is dv dx. I think shouldn't be an issue. This is 1 minus x half. Then you just v equals to 1 minus x 3 over 2. Then 3 over 2 minus 1. Okay? So key this in. v minus 2 third 1 minus x 3 over 2. So once you do it, uv minus 2 third x 1 minus x 3 over 2 minus v du dx, which is 1. Not an issue there. I think by parts here should be quite okay. Okay, so this one here, just put it aside. Done. So once done, do this. Minus 2, 3x. 1 minus x. 3 over 2. Plus 2 over 3. I just do this straight. Minus 1 plus c. So this case will be minus okay. So for part 2, use the substitution. I think substitution we all know very well. So you differentiate with respect to x. So part 2, u square, right? It goes to 1 minus x. So you should, no question, I'll just differentiate with respect to x. Then this will be 2u du dx equals to negative 1. Okay. So this case here, what you get is guess what? 2u dx. So this case here, you will get make dx a subject. Now, a lot of schools don't allow you to write this, but like I say, these are all in university textbooks. So in A level, I think it's perfectly fine. But in A level, you don't need to erase it if you don't feel like it, but it's fine. Okay. So what we're gonna do is actually for I, this is x 1 minus x half dx. So then we have got x here, which is 1 minus u square. No an issue. So I'm going to put 1 minus u square here. Then 1 minus x will be u square half. I know that u square, this is u square. Then this x is 1 minus u square. Okay. Then dx will just be minus 2u du. Okay, change everything to u. Not an issue there, so just put the 2 outside here. 1 minus u square u1 times u du There will be yep. It will be u cubed over 3. Okay, maybe you put this as C2, then the previous one as C1. So you replace this back in, u will just be 1 minus x half, right? So this case will be yep. Can you answer me why that you need to show that the difference between 1 and 2 differ by a constant? These are the kind of question which is like the one that in my mock paper, right? A lot of concept. So let me explain. Now, do you realize that the answer in part 1 and part 2 looks different? Okay, looks different. Now, but are they equivalent? You expect them to be equivalent. So for example, right, if you say I from 1, right, you say I part 1 is you integrate from part 1. You get a function of x plus c1. Then part 2, you get same I, this is same I. You get a function of another function of g, you call it gx equals. Now, you expect them to be equivalent, right? Okay, so if this is true, if they are equivalent, what will happen? Meaning to say fx minus gx is equals to c2 minus c1. You see that? So you see that this is a constant? If and only if when they are the equivalent, right, then only this will be a constant. So this tells you that this constant here is actually trying to tell you that it's only a constant when the answer in 1 and 2 are equivalent. Understand that? So please understand what they're asking you. Don't just do the question without understanding the beauty of the setup. The setup is that because although 1 and 2 looks different, but they are all the same. Okay, in its core, they are the same stuff. So that's the idea there. So what is the first thing you should do before you even start? What should you do? Can you tell me what you should do? What will you do? What would I do? I'll tell you what I'll do. I'll key this into calculator and key this into calculator. Take this minus of this, and I expect it to be a constant. Understand? Before you even start, right? Key into calculator and see whether they are the constant. So this is, I think, I'll key in. So once we done that, what I'm gonna do is I'm just gonna key in calculator here. So I think we all know how to key in calculator. So I'm gonna leave all these to you. So I'm gonna key this one here. X. Then we have minus 4. Okay. Then you minus off the one below. Minus of negative 2 over 3. 1 minus x. Then you just pass. 1 minus x. Okay, so once you're done already, you just go to our table value or graph. Graph, you'll see that it's the same value all throughout. The y value are all 0 here. You see that? All 0 except, okay, all those are zeros. You can actually go table value, you see it's all 0. It's error for the first part because x has to be less than 1. I mean, less than 1. You cannot root a negative number, so that's why. So it shows that I know that the difference should be constant. So just check first before you. If you don't get a constant when you minus using GC, meaning something is wrong somewhere. So go and do the checkup. Okay, so part 3, what I can say is that answers. So we take answer in 1 minus of answer in 2 would be minus of okay, there you go. So once done, you just okay, just slowly careful. You see that all these, okay, this one here, there's x here, there's no x here. So you try and just factorize something out. This is algebraic manipulation. I think from here is all algebra. So be careful. So this is minus. I will suggest bringing out the minus x 3/2. 1 minus x 3/2. Okay. So because this guy here, I need to force a 3/2. So I know 3/2 is equal to 5/2. So this one. Okay, so then same thing. I'm just gonna factorize the 3/2 out. So there you go. So these are the same stuff. This one. I factorize this out. Yeah, factorize this. Okay. Then you just hope that this is 0 lah. This I think this whole thing is 0, right? Just now we key in just now this whole thing is 0 here. So we see whether any colors mistake. Colors mistake. So be careful. Is 0. Okay, let this be D lah. Okay, if they ask you to explain what's the significance of this, you can just say that this implies that the answers are equivalent. Okay, so this implies, yeah, the interpretation is basically answer. This implies that answers one and two are equivalent. Okay, so if they ever ask you, you know what to explain. Of course, this question they did not ask. If they ever ask, then you will know how to explain.